In this video, I will show how to sketch the graph of a rational function and use it to solve the inequality. First, we start by finding the domain of the function. And domain of the function we find by factoring out the denominator. So x squared minus 1 can be factored into x minus 1, x plus 1. And from here we see right away that x is not equal to -3, x is not equal to 1, and x is not equal to -1. Next, what we do is we classify the discontinuities. So we just learned that we have 3 discontinuities at -3, 1 at -1, and now we want to know whether we have a removable discontinuity or an asymptote. So to classify discontinuity, we have to write the function in reduced form. So that means we want to factor the numerator as well and see if anything can be reduced. And we can see that x minus 1 is in both the numerator and the denominator. So when we reduce by x minus 1, we have no x minus 1 factor in the denominator. That means x equals 1 is classified as a whole, and at x equals -3 and x equals -1, we have vertical asymptotes. So we can graph those right away. So at -3 we have an asymptote, and at -1 we also have a vertical asymptote. Next, once we've found vertical asymptotes, we would like to find out whether there are horizontal or slant asymptotes. So to find out whether there are horizontal or slant asymptotes, we have to consider the degrees of the numerator and the denominator. So here we see that degree of the numerator is 2 and degree of the denominator is 2. So we have same degrees. That means that we have a horizontal asymptote which has an equation y equals the ratio of the leading coefficients of each of those polynomials. We have coefficient 1 and coefficient 1 in both the numerator and the denominator, so we're going to have the horizontal asymptote y equals 1. So we can just write it as y equals 1. And we can plot that. Next, we construct the sign chart for this rational function. How do we construct the sign chart? We plot all the zeros from both the numerator and the denominator on the number line. And whichever one has an even multiplicity, I would mark with an exclamation mark. Since all of these zeros have multiplicity 1, I don't put any exclamation marks on the sign chart. I mark the ones that came from the denominator with little circles just to remind myself later on. Now, to fill in the sign chart, we have to figure out the sign on at least one interval, and if we remind ourselves that we have a horizontal asymptote, which means that your function must be positive on the very right and positive on the very left, that means we can label the rightmost interval with a plus and leftmost interval with a plus. And now, since there are no exclamation marks at any of the zeros, that means the function changes the sign as it's going through each of those points. So on this interval it will be negative, then positive, then negative, and then positive again. So this is the sign chart. Now with the sign chart, we can now figure out the behavior near every asymptote. So at -3, the function is positive on the left and negative on the right. At -1, it is negative on the left and positive on the right. And we also have zeros at 1 and 4. And at 0 at 1, we have a function crossing from positive to negative. And at 4, we have a function that crosses from negative to positive. I also want to remind you that the horizontal asymptote only tells us what the function looks like as x goes to the right and to the left. So that means function can cross the y = 1 line anywhere in between. So now we have everything that we need to sketch the graph. So we simply just have to connect the dots and the arrows. So going from right to left, function goes to 0 at 4, passes through, turns around somewhere, we don't know where, goes to 1, crosses at 1, and goes to infinity as x approaches to -1. On the other side of -1, it appears from the bottom, turns around somewhere before hitting the x-axis because there are no x-intercepts, and goes to -infinity at -4. Appears on the other side and goes to horizontal asymptote. So this is the sketch of the graph of this function. Now, how do we use this graph to solve inequality? I forgot one thing. We had a hole at 1. What does that mean? That means on the final graph, what we have to do is we have to remove a point at x = 1. So it happened to be the x-intercept, so I'm just going to draw a hole. And now, to solve inequality, we can simply look at the graph, and the question is for which values of x the graph of the function is below or on the x-axis. It is pretty clear that it is on the interval from -4 to -1. The entire piece is below the x-axis, and on the interval from 1, not including 1 because we have a hole there, and going to 4, including 4 because inequality is not strict. Now, as a matter of fact, we could have used the sign chart to solve this inequality because the sign chart, the only purpose of the sign chart is to tell the signs of the function. And I just found a mistake here. Instead of -4, this should be -3. So this is how we sketch the graph of a rational function and use it to solve the inequality.